let us understand the magnetic field and field lines with the help of the following activity. Take a small compass and a bar magnet. Note that the red end of the magnet is the North Pole, and blue end is the South Pole. Place the magnet on a sheet of white paper fixed on a drawing board, and mark the boundary of the magnet. Place the compass near the North Pole of the magnet. The South Pole of the needle points towards the North Pole of the magnet, and the North Pole of the compass is directed away from the North Pole of the magnet. Mark the positions of the two ends of the compass needle. Now move the compass to a new position, such that its South Pole occupies the position previously occupied by its North Pole. In this way, proceed, step by step, till you reach the South Pole of the magnet. Join the points marked on the paper by a smooth curve. This curve represents a field line. Repeat the same procedure, and draw as many lines as you can below and above the magnet. You will get a pattern of lines. These lines represent the magnetic field around the magnet. These are known as magnetic field lines. This magnetic field is the region surrounding a magnet in which the force of the magnet can be detected. The strength of a magnetic field is indicated by the degree of closeness of the magnetic field lines. They are close together at the two poles of the bar magnet. So, the magnetic field is strongest at the poles. For this, observe the deflection in the compass needle as you move it along a field line. The deflection increases as the needle is moved towards the pole. The magnetic field has both direction and magnitude. They emerge from North Pole and merge at the South Pole. Inside the magnet, the direction of field lines is from its South Pole to its North Pole. Thus, the field lines are closed curves. No two field lines cross each other.
It's probably safe to say that you have a very good idea of how the magnetic field of a bar magnet looks like. But do you know the 4 important properties of magnetic field lines? To find out, let's begin by plotting some magnetic field lines. You need a pen, plotting compass, and a magnet. My magnet doesn't tell me which is the North Pole and which is the South, but we'll find out soon. Place your magnet in the middle of the page and trace around it. Place the plotting compass near the magnet. Mark the direction that the compass needle points by drawing a dot. After the first plot, move the compass so that the back of the needle lines up with the dot. Repeat this until you reach the end of the magnet. Join the points together to show a field line. I'll also draw an arrow here to show the direction that the needle is pointing in. I'll do all of the above again with another starting point. Looking at the field that we've plotted, we can figure out the 4 main properties of magnetic field lines. Number 1. Magnetic field lines never cross each other. They never overlap. Number 2. they always point from the north pole of the magnet to its south pole. North into south, so that must mean that this is north and this is south. Number 3, they are continuous. The only reason these lines have been cropped out here is because I've simply run out of space. Number 4, where the lines are closer together, the magnetic force is the strongest, and that's at the poles of the magnets.
Let's consider a bar magnet. Its shape is similar to that of a chocolate bar. It has two ends on the opposite sides where N and S are written. Do the ends have any significance? These two ends are called the poles of a magnet. The one where N is written is North Pole and where S is written is South Pole. From the last video, we now know that there is an invisible magnetic field surrounding it. And if you place any magnetic material in this field, then it will be attracted towards the magnet. But this field is invisible to us. However, there is one way in which we can visualize it. How? Tie up this magnet with a piece of paper with the help of a sellotape. Keep it on the table and turn it upside down so that the magnet is on the lower face of the paper. The magnet is between the paper and the surface of the table. Mark the position of two poles of a magnet on the upper face. This place is above the North Pole and this one is above the South Pole. Finally, sprinkle some iron filings on the upper face slowly so as to cover the entire area surrounding the magnet. What will we notice? We will find that the iron filings arrange themselves in a specific pattern. This pattern not only shows us the pattern, but also tells us a lot about the strength of the magnetic field of a bar magnet. First of all, iron filings are nothing but very tiny pieces of iron, which is a ferromagnetic material. So they are attracted by a magnet. You will see that more iron filings are gathered at the two specific locations and less elsewhere. These two are the locations directly above the two poles of a magnet. So the iron filings are attracted more towards the poles of a magnet than the center. But what does this tell us about the strength of a magnetic field? More iron attracted at the poles means that the field at the poles is stronger. And consequently, the field is weaker at the center. Not only a bar magnet, every magnet has a different field pattern. This field pattern depends on the shape of a magnet. Yes, different shaped magnets have different field patterns. For instance, here is the field pattern of a horseshoe magnet. You can see that more iron filings are gathered around the two poles while less so elsewhere. In the next video, we will see different types of magnets. See you there.